So far, you've simplified radicals, you've added and subtracted them, and even multiplied them. Now we're going to divide. So, we know how to divide numbers in fractions. That's easy. But what about when you've got that radical symbol there as well? So, the first thing I want to note is that these indexes have to match. So it has to be a square root over a square root, or a cube root over a cube root, or a fourth root over a fourth root, or so forth. But if those match, then you can actually, just like when you took and you had it and you were multiplying them, and you could just multiply them together. If they have the same type of root, you can just take the root of them together. Very similar idea. So you can just divide them. So on this one, if we look at the coefficients, we got 12 over 2. That's 6. And if I take 160 divided by 5, because those match, they're both square roots, I get 32. So I've got the square root of 32, which can simplify. 32 is divisible by 2. 2 times 16. Oh, 16 is a perfect square. So this is the square root of 16 times the square root of 2. That's a 4. 4 times 6 is 24. For the sake of time, I'm just going to kind of go through the ones on the first column here. We have no coefficients on this one. X cubed divided by x squared. Well, that would just be an x. But it's still in the square root, right? Because we haven't undone that yet. Y to the 9th divided by y to the 5th is y to the 4th. The square root of x, I can't do anything with that, but I can take the square root of y to the 4th. Because that'd be 2 sets of pairs. I'd have y, 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 y. I'm not whining. I'm just talking about y's. So I'd have y squared, square root of x. Oh, this one's already put together. So it's all in the same fraction. So 48 divided by 16 is 3. So that's just the square root of 3, which is beautiful because I can't go any simpler. Let's see on this one. Okay. I can't really divide 7 and 64. I can't divide an x to the 5th and a y to the 6th. So this one I'm going to actually use that quotient rule to split up to see what I can do. So just like I could take the radicals and put them all together, I could split them back up. So I can make this into the cube root of 7 times the cube root of x to the 5th over the cube root of 64 times the cube root of y to the 6th. Let's see if we can simplify any of those. Well, in the numerator, I can't simplify that, but x to the 5th has a set of 3 x's, so 1 x gets to come out. The 7 will be underneath along with x squared. In the denominator, the cube root of 64 is 4. And the cube root of y to the 6th, there'd be a group of 3 and another group of 3, so I'd have y squared come out. Now, the next skill is called rationalizing the denominator. You should have seen this in geometry and possibly in Algebra 1. In traditional mathematics, back in the old days, we didn't have calculators that had square roots in them, and we had to look it up on tables and stuff. And so it was really hard to divide by a square root. So traditionally, we preferred to have it as a multiplication. So we did not ever want to have a radical in the denominator. So rationalizing the denominator means no radicals in the denominator. Now, the process to get rid of the radical in the denominator is pretty simple. If you just have a square root in there, and there's no adding or subtracting or anything, the process is to multiply the numerator and the denominator by that radical. So I'm going to multiply the top by square root of 5 and the denominator by the square root of 5. And watch what happens. I'll get 3 square root of 5 over 2 square root of 25. But what's the square root of 25? It's just 5. So this is going to come out as a 5, and 5 times 2 is 10. So what would I do in this one? I'd multiply the top and the bottom. So this is the square root of 8 over the square root of 15. I'm doing that because I can't simplify 8 over 15. I'm going to multiply the top by the square root of 15 and the denominator. That is going to get ugly really fast. So I'm going to kind of leave it as 8 times 15 for a second. And the square root of 15 times the square root of 15 is just going to be a 15. This is a 4 and a 2, right? 4 and a 2. So the square root of 4 is 2, so 2 gets to come out. This 2 and the 15 stay in. And this is considered simplified. We have no perfect squares under the square root, and we do not have a radical in the denominator. So what would I multiply by on this one? Well, I'm going to multiply by whatever radical was in the denominator. So that would give me, let's see, 3 times the square root of 12 times the square root of 7 over 4 times the square root of 49, which is just going to be 7. 12 has a 4 and a 3. And the square root of 4 is 2. So 2 times 3 is 6. And then I have a square root of a 3 and a 7. That's 21. Over 28. Ooh, I can go one step further. I've noticed that 6 is even and 28 is even. So I can simplify 6 over 28 to be 3 over 14. Again, the denominator is a single square root. So what I'm going to do is multiply the top and the bottom by whatever that radical is. So I'm going to multiply by square root of 2, and I'm going to have to multiply the whole thing, and then multiply this one by square root of 2. So I'm going to have to distribute up here. Square root of 2 times the square root of 8 is the square root of 16, minus square root of 2 times the square root of 2 is technically the square root of 4, and then I have the square root of 4 in the denominator. That's going to give me 4 minus 2 over 2. Oh my goodness, does this one look nice? And I get a 1. Last but not least, the funky ones. So, notice that we have this addition or subtraction in the denominator. We are going to multiply by what is called a conjugate. It's almost like that denominator, but instead of 4 plus the square root of 2, I'm going to multiply the numerator and the denominator by 4 minus the square root of 2. And let's watch the magic that happens when I do that. So we need to do some distributing. 4 times 4 is 16. 4 times negative square root of 2 is negative 4 square roots of 2. In the denominator, I'm going to have 4 times 4 is 16. 4 times negative square root of 2 is negative 4 square root of 2. Now distribute this square root of 2. Square root of 2 times 4 is positive 4 square roots of 2. Square root of 2 times negative square root of 2 is negative square root of 4. Aha! Look what happens to that middle term. And guess what? It always does. So in the denominator, I have 16. Those two cancel out. And the square root of 4 is 2. So 16 minus 2 is 14. Yes. Now notice that all of these are even. I can divide both the numerator and the denominator by 2, but I have to divide all the coefficients. So this would be 8 minus 2 square root of 2 over 7. And don't divide the 2 in the inside because it's inside the radical, and these are all coefficients. They're on the outside. What would be the conjugate of 1 minus 4 root 2? Well, it's going to be 1 plus 4 root 2. So in the numerator, when I distribute, square root of 3 times 1 is square root of 3. Square root of 3 times 4 square roots of 2. The 4 is outside, and the 3 and the 2 are both in, so they become 6. In the denominator, 1 times 1. 1 times 4 root 2. Negative 4 root 2 times 1. The negative times a positive is a negative. 4 times 4 is 16. And that'd be this 2 square root of 2 times square root of 2 is square root of 4. Let's see if we can clean this up a little bit. Notice that this denominator, those middle terms always cancel. Alright, so I have a 1 minus 16 times the square root of 4, so that's going to be minus 32. Which is negative 31. No more radicals in the denominator. The conjugate to 2 plus 2 root 7 is 2 minus 2 root 7. Distribute. Now this one we're going to have to do a lot of distribute. I'm happy it's at the end of the page. I might have to go all the way down here. 3 times 2 is 6. 3 times negative 2 root 7 is going to be negative 6 root 7. Then this would be positive 2 root 7. Then I'd have negative 2 root 49. And I'm trying to show everything here. In the denominator, 2 times 2 is 4. That'd be a negative 4 square root of 7. A positive 4 square root of 7. Negative 4 square root of 49. So each of those square root of 49s are actually 7s, right? That's really a 7, and that's really a 7. So I've got 6. These two combine and give me a negative 4 square root of 7 minus 14. These two cancel, and I've got 4 minus 28, because 4 times 7. Clean it up a little bit more. Combine like terms. Oh! All 3 of these coefficients are negative, and all of them are multiples of 4. So I can divide the numerator and the denominator by actually a negative 4. That would give me a positive 2 plus 1 root 7, and then that would be a positive 6. You can only do that when it affects everything in the numerator and denominator.